All right, so for this question, you've got f of x is equal to x minus 2, and they tell us that it passes through the point 6 comma 4, labeled right there, obviously. What will be the new coordinates for f of 2x? So the thing about f of 2x that you need to realize is that this is a horizontal, and if it's a 2 on the inside, which is bigger than 1, that's going to be a compression, okay? This is a horizontal compression of the function. All right, so what this is going to do is it's going to push all of these, every point that's on this line, is it's going to push it inward horizontally. It's going to compress it inward towards the y-axis, all right, by a factor of 2. So basically everything is going to get divided by 2, uh, just the x values though. Like all the y value spots are going to stay right where they are. But say like this red point that I was focusing in on, it's going to get sucked in by a factor of 2. So it would land right here. This would be its new coordinates. All right, but we want to do this for the point 6 comma 4. So its new location, it was 6 to the right, but since that is getting divided by 2, it's going to be at a 3. Right? This would be its new location. And it's still going to have the same y value. That's the key there. All right, so since we're messing with the inside of the function, we're just messing with the x values. We're not messing with the y values. So what our answer is going to be is 3 comma 4. Okay. Another way that you could have done this one, which wouldn't have been as effective, is to actually find f of 2x, which means you would have replaced that x with a 2x. So it would have been 2x minus 2. And then if you remembered how to graph that from your Algebra 1 days, you could have graphed the new equation and just looked for which of these points down here was also on that line. Okay, it's not as effective. I want to go ahead and switch over to another page here. Just another example, because I know these are really tricky to grasp. All right, so I've got some made up function. I'm not even defining the function, but I know that it passes through 10 comma 20 here. And I want to know where this point will get transferred in each of these 4 situations. Okay. So if you want to pause and try it out, each of these represents a transformation, and you could try to determine, predict where that point's going to go. Okay, so this one is a flip across the x-axis, and so it's going to take this point and it's going to reflect it across our x-axis here. So it's going to end up down here. Notice the x value stayed the same, but the y value switched signs, right? Instead of it being at a 20 right here, now it's got a distance of negative 20. So the coordinates would be 10, comma, negative 20. That would be our answer. On this one, f of x minus 4, this is a transformation 4 units to the right. So think about what the coordinates of that point will be if we moved it 4 to the right. Right, it would still have the same y value, but its x value would be at a 14 instead of a 10. Okay. So the coordinates would be 14, comma 20. All right, 1/2 f of x. All right, this one is a vertical compression. All right, we're multiplying the outside by a small number. And so what this is going to do is it's going to take every point on the function and it's going to smush it down. It's going to compress it towards the x-axis. All right, and so it's going to get sucked in by a factor of 1/2. So if it was 20 high, now it's going to be 10 high. So my x values are staying the same in this situation. Okay, my x is going to stay a 10, and my 20 is going to get changed to a 10. So 10 comma 10 would be the new location. All right, f of 5x. This one is a horizontal compression. And so this point is going to get sucked in closer horizontally towards my y-axis here. All right. My y values are going to stay the same, but my x values, 10, it's going to get divided by this 5 right here. All right. It's going to get sucked in by a factor of 5, so it's going to land about right there. Its distance is going to be 1/5 from what it used to be. So my 10 is going to change to a 2, and my 20 is going to remain the same. Okay, there you go.